Hello and welcome to the Section 6.3 lecture today. Today we're going to talk about writing equations of parallel and perpendicular lines. I guess to start, just the idea of what parallel lines are, we're looking at lines that never cross. Lines that never cross. Basically they stay the same distance apart everywhere. So looking at a couple examples, and these are going to end up being parallel lines as I check out their graphs. So here's one of them. And then the other one. I think we'll go through there. Yep. Sorry, I was trying to do my lines as quick as I could. So those are parallel lines. Not too bad, right? We think of them as like railroad tracks. The two ends of the railroad tracks are never gonna, or two sides of the railroad tracks are never gonna cross. Sorry. So those two sides are never gonna cross. And so in the equations, what we want to see is what's the same and what's different, and what could be the thing that affects whether lines are angled at a way that they cross. And you may already know, or if you don't, maybe you're not too surprised to find out that it's all about the slope. Okay? We say that parallel lines have equal slopes. Okay? And so as long as the two slopes are equal, those two lines are going to be parallel. Because think about what that means. A slope of 2 means go up 2 and over 1. Well, if one line goes up 2 and over 1 and the other line goes up 2 and over 1, the lines are never going to catch each other. Like I always think of the one that's down here, he's never going to quite make it to him because they're taking the same, the same leap, the same jumps. Okay? So when it comes to writing the equation, it really turns into, all these problems really turn into the thing that we talked about in 2.1, I think. Yeah, we're on, sorry, not 2. Okay, yeah, we're on 6.3. So this actually came from 6.1. These all kind of turn into given slope and a point. That's what all these problems really turn into. And so we talked about a couple different ways that we can do any of that we could do any of those. And I'm going to leave it to you on which method you use. But all you need to do is, it says write the equation line that is parallel to the line here, that passes through here. The only thing we care about in this entire equation is the slope. Once I have the slope, I know that if I want it parallel, it's going to be the same slope. Okay, so I want a line that has a slope of 1/2 that goes through the point -3, 2. So maybe we do that the slope-intercept way. This is what we talked about in 6.1, x plus b, and then we've got a y of 2. And of course it can't work out perfect for us. -3 plus b, and we want to solve that. So we've got, I didn't really give myself a whole lot of room to do this. -3/2 plus b, add 3/2 to both sides. That's 1.5. So that's going to be 3.5, which is 7/2 is equal to b. So we get y equals 1/2 x plus 7/2. Go ahead and pause the video and try the next one. Use the same strategy if you want. Hopefully you had a chance to do that. Let's go ahead and see how you did. So again, I want a line parallel to this one, and the only thing I care about that is the slope. It says that the slope is 3. So 3x plus b, put the 5 in for y, 2 in for x, 3 times 2 is 6, and when I subtract 6, I get negative 1, and so we get y is equal to 3x minus 1. Again, remember we did talk about the point slope form method, where you just plug all the things you know into point slope form and then solve it for slope intercept form. Or, I mean, I guess technically you could just put it in slope intercept form and call it done, because that's technically an equation. I'm going to make you work a little harder and write it in slope intercept form. You would like that better, so why wouldn't I? Why wouldn't I make you put it there? All right, let's look at the next idea. Perpendicular lines are lines that meet at 90-degree angles. That's what perpendicular means, meet at right angles. And let's take a look at these two lines. So the first one I have starts at 3, goes down 2 and over 1, down 2 over 1, down 2 over 1, and it'll continue doing that. I'm just going to kind of do this the hard way. Oh, you dang it. Do this the hard way. It's never fun, but it is the best way to get through the points that I have. And then the next one goes through -5, and it goes up 1 and over 2. So I think with that much information, I can make a pretty good line. I think it should go through there. Yeah, that's good enough. Let me get some of these pencil marks out of here, some of these points out of here. And so we can just see these two lines, I guess, in general. So these two lines are perpendicular. They meet at a right angle. You might see on a picture that these two, you might see this little filled in, or not filled in, but outlined square right here. And that would mean that these two meet at a right angle. And so and obviously from knowing about parallel lines, we know that perpendicular lines have to involve the slope, because we're talking about how two lines meet. So what is it about the slope that makes these perpendicular? We would say that perpendicular lines verbally, we say that they have opposite I'm going to say plus, minus, opposite, plus or minus, reciprocal, I'm going to say flip, slopes. And you'll see this quite often. If two lines are perpendicular and they have slopes m1 and m2, you would say that the slope of m2, the second line slope, would equal -1 over the slope of line 1. Okay, so that's kind of a mathematical way to flip things, is put any number under 1 and it flips your fraction, whatever you might have. Okay. I like to think of it as flip the positive or negative sign and then flip the fraction. It tends to work pretty well. All right, let's get going with a couple examples. So these ones are given to us in standard form, so we do have to work a little bit. And the way we would do that is we're going to solve each one of these for for y, so we know the slope. So I'm going to go ahead and subtract 3x. Get 5y equals negative 3x plus 12. And then I'm just going to divide by 5. Now I'm going to divide by 5 everywhere. I don't really care about much other than this part right here. Okay, I know that my new slope is going to be negative 3 over 5. Okay, and that comes from this part right here. I don't care about the 12 over 5, even though like that's part of that equation. The key is that's part of that equation, not the one that I have. And so, sorry, I'm having a tough time this morning. I get y equals negative 3/5 times x. I don't like that. I tried to save it. Unsuccessfully. Times x plus b. Plug in my x for x and y for y. So my y is 5. My x is negative 10. And we get plus b. Negative 10 times 3/5. Well, the 5 and 10 kind of cancel. And it gives me a 1 on the bottom and a negative 2 on the top. So this really turns into negative 3 times negative 2. So we get positive 6. And we've actually dealt with this today. When I subtract 6, I get negative 1. So we get y equals negative 3/5 x minus 1. Okay, go ahead and pause the video and try that last one. Okay, hopefully I had a chance to do that. We were looking for an equation perpendicular. Oh, wow. Okay, well, I messed some things up, didn't I? I found parallel, even up above. If you caught that, that's great. If you didn't catch it, that's okay, because I didn't either. And it's actually going to make this a lot nastier than it should be. Because I'm finding perpendicular, I need the opposite, so I'm going to get rid of the negative sign, and I'm going to flip the fraction. So I get 5/3. Now that's not as nice. It's just not like at all. That's going to be negative 50 over 3. And 5 is going to be 15 over 3. So we're going to have 15 over 3 equals negative 50 over 3 plus b. I'm going to add 50 to both sides, so that's going to be 65 over 3. And yeah, that's not going to come out to anything nice, so we're going to leave it as 65 over 3 as our y-intercept. I got a little bit ahead of myself on that last problem. I will admit that, and I apologize. So we get 5/3 x plus 65 over 3. I got so excited on that previous problem, I found the slope, and then I just like, oh yeah, I found it, so that's good. Forgot that we're trying to find perpendicular, not parallel. All right, let's look at the next one. Equation of a line perpendicular to 4x plus 2y. So we'll go ahead and subtract 4x. We get 2y equals negative 4x plus 10. And then we can divide by 2. And I get negative 4 over 2, which is negative 2. Maybe this will help if I actually write it out first. I don't think it will, but it might. And then so my new slope, I want to flip over negative 2 and flip the sign. So my new slope is going to be 1/2, right? Because I took negative 2 over 1, flipped it over, and changed the sign. So then we get y equals 1/2 times x plus b. Put our values in. I got negative 1 for y, and I get 1 for x. And so that's going to be negative 1 equals 1/2 plus b. I got to subtract 1/2 from an already negative 1. And so that's going to be negative 3/2. B will be negative 3/2. And we get the equation y equals 1/2 x minus 3/2. And that'll be it. So, barring that one little mistake, I think we had a pretty good day. Make sure you get any questions down that you have. Otherwise, have a great day, and we'll see you in class.